But yeah, so I'm an architect. I've been at Space Syntax for almost coming up about 18 years, so quite a long time. Ilaria left, I think, about a month before I joined, and I used to sit at Ilaria's desk because everything had stickers on it that had her name on it. So the keyboard, every piece of stationery had Ilaria's name sticker stuck on it. Although we never actually worked in the same, we never worked there at the same time. Anyway, what I was going to show you today was some work about integrated urban models, and it was really to talk about these and to go through, I mean, it's put together to talk through kind of four main things. One, to say, why do we need these models? What are they and why are they different? How have they been validated? So how do they help you prove, how can they prove that something really is happening? And then to say, how have they been used? What I wasn't going to do was I wasn't go into the detail about some wider positioning. I might mention things a little bit about complex systems and cities as complex systems, but I'm not going to go into any real detail on that. It's going to be a bit more kind of focused to talk about what are the elements that we include in an integrated urban model and how do we use them. So the starting point is about space syntax, and I'm not sure how much people know about space syntax. My assumption before was that people would have heard of space syntax spatial network models, but I was going to do a really quick recap just to make sure that people had the same starting point, and then we can talk about how they're different or how integrated models are different. So the space syntax spatial network models, these are based on the work that Bill Hillier was doing at UCL from the 1970s onwards. And they're really based on this idea that as people move through a city in space, what you see changes. And depending on what you can see, affects how likely you are to go into a particular space, how easy it is to get in or out of them. And actually, if we can represent the spaces in a city, we can analyze them from the perspective of a person. So how well connected are each of these streets on the basis of how easily you can see in and out of them. Then that can start to explain, a whole series of hierarchies within the city. And sorry, that's not meant to change that quickly. But so you probably have seen these models where we have, sorry, this is on some timer setting. I'm going to, sorry, hang on. It shouldn't be going through that quickly. I'm going to see if I can pause it. Let's just see if we can leave it on this. So the point with the spatial network analysis is that you've probably seen things like this where it will pick out in colors a set of hierarchies within a city. So it will be able to show you, depending on how you're analyzing that system, red will show you typically something that is better connected. And there's different ways of measuring how well something is connected. If it is close to everywhere, if it's easy to get to, that's one set of measures that we often talk about as centrality or integration. There's another set of measures that talk about how likely it is that someone will use that street on a journey from anywhere to anywhere. And what that starts to do is pick out a route hierarchy. It shows you the places that people are more likely to use. So the really important thing with these spatial network models is that these hierarchies relate to actual things which happen in a city, which are observable and which are measurable. So if you were putting this into the language that people talk about complex systems, these are emergent activities. So these are things that happen almost by themselves over time. So what the spatial network models are really good at is to be able to explain, if you look at how well connected the streets are, that will typically describe where you get higher levels of pedestrian movement. So you can start to see those sorts of things. You can then start to see, this is where it begins to get interesting as well, is that, I'm sorry, I don't know what's happening with the timing of these slides. Once you can see where there's pedestrian movement or where people are, there are certain things in a city that need to be close to people and certain things that need to be further away from them. So a really good example is land use. If you're looking at things like shops, if you're going to open a shop, you need to have customers walking past. So you need to have footfall. If we know that footfall follows the red lines, if you look at London, 80% of the shops are on the red lines. So we can start to see these relationships between the spatial network, the amount of movement that happens, and then the land use. And so these spatial network models are really good. They're really light touch. You don't need a lot of information to make them. It deals directly with space. So if you make a model of a spatial network, it's then very easy to feed that back to a design team, because you can show them, you need to change the shape of this building, or you could try making this new connection through here, and you can literally translate that into a design. So they're really good from that perspective. Some of the things that they are not quite so good at, though, is that the only real variable in these models is the spatial network. So that means that if you want to change an area, almost always the only way of being able to model the impact of it is to be able to make a physical change, and you can't always do that. That could limit the way that you use the models to be places which are either growing or to be brand new developments. The other area where they could be better is that you need to understand what a space syntax model is to be able to interpret it. So you need to know what's a red line, and what does that mean if it's a red line? How does that relate to the thing I'm working on? And is this the right answer for what we're trying to do or not? You need to really be able to understand space syntax. And so integrated over models kind of pick up on these kind of two things. They also pick up on a whole load of opportunities that came about through tech development over the last 10 years or so. So those big changes included things like more data being available, better software, better computers, but also better coding skills, that lots of graduates could code, probably in Python, but often in something else as well. And what that meant was that you could make a bigger model, it was more complicated, and you could process it quicker. And that's, for technical people, that's quite interesting to just try and do that anyway. But the real question is, so what? Why should you try to make this bigger, more complicated model? And one of the reasons is that you don't necessarily need to be trained in space syntax to be able to understand the answers. Another thing is that it means that you can talk about showing the impact of changes to land use or public transport in a way that you can't directly do in a spatial network model. So to give you some examples of this is quite often the sequence that we show to talk about what we're really trying to do. And this is pulling together a whole load of different kind of themes. Some of it is around complex systems, some of it is around built environments, some of it is around outcomes. And this is a story that was in the BBC. This was taken from 2018, but these stories are still coming out. And the story really is that people are moving into brand new houses, and then they're really unhappy that they spend the whole time driving everywhere. In this particular example, the town centre is just the other side of these houses, but these people can't actually walk to it because of the way the street grid has been designed, because of the way the public realm's been designed, because once you get away from this, once you get out of this housing estate, you're cut off by big roads that are very difficult to cross. They're not nice to walk next to, all of those sorts of things. People end up driving everywhere. So people are moving into brand new places and they're becoming car dependent. And on one level, it's just inconvenient that you have to drive everywhere. On another level, there are these more and more medical research coming out that is talking about the relationships between what people do on a daily basis and long-term outcomes that are really serious. So things like health. This particular example is talking about there being a reduced risk of obesity in people that take public transport to get to work. So that's not even active transport. That's just walking to the bus or the train. That little bit of activity reduces people's risk of obesity. And that doesn't just have an impact on the individual, that has an impact on society. So it might be that there are fewer people who need treatment for the conditions that are often associated with obesity, and that will save money to health services, to all of those kind of things. But there was this paper that was done across the EU back in about, again, 2018, 2019, I think, and they were looking at all of the secondary costs. So not just health, but they were looking at the cost of impact on climate change and the benefit to local economies and all of these sorts of things. And what they were able to show was that driving cost society equivalent of 11 cents per kilometre. Cycling and walking, they don't just break even, they don't just have a lower cost, but they generate a benefit. So they're more than saving money, they're actually generating money. And that's through things like the local economic things as well. Now, the really important thing, and the reason that modelling becomes important is because you don't have to build this thing, see what happens, and then understand the impact. What we really want to do, I mean, one way that I've talked about this in the past has been to talk about it as trial and error. So you build something, you see what happens, and then you try and correct it. The reason for using models is that you can start to understand the conditions that make somewhere walkable or car dependent. Then what you can do, before you build it, you can start to test somewhere. So you can see if it's car dependent, then you can work out how to change it. You can see, does the street layout need to change, or does the land use need to be distributed differently? So if we can make better use of modelling, we can avoid this whole process. And instead of building it and seeing what happens and then correcting it, we can make sure that when you build it to begin with, it puts in place the conditions that make positive outcomes possible. So this point about outcomes is where we have to be really careful and to be really precise about things. So outcomes, especially things around health, are really, really complex. Now, this is a piece of work that was done by a group in the UK government a while ago, probably 6 or 7 years ago. And what they're looking at here is all of the factors that affect whether people become overweight and obese. And there's loads and loads of different things in here. Some of the stuff in here depends on people's income. It depends on whether they've inherited conditions from their parents. There's lots and lots of different factors. And a lot of those factors, if you're a planner or a designer, you can't control them. So what we have to be really careful with as designers is to say, oh yeah, we can design this thing perfectly and it will completely remove obesity, because it can't do that. What you can do though, and this is, in this particular example, it's really helpful that they have started to group these factors together and put them into kind of families. So you can see those points that I was just making, these things around conditions that you might inherit and what food you eat and all of those sorts of things. The bit that is really important for designers and planners is that this group over here has been classified as the physical activity environment. So that's the environment, that's the stuff that we can actually control. So we might make this perfect, but somebody still might decide that they're going to eat really unhealthy food, or they still might not do any exercise. You can do all of this bit. This is the bit of the diagram that we're responsible for. If we get our bit completely right, you can't guarantee a positive outcome. You can make it possible. I know there's maybe a conversation with Ilaria that I know we have different ways of talking about it. And I think Ilaria's preferred way of talking about it is that if everything else stays the same, we can get better outcomes if we get this bit right. So there's different ways to talk about it. But the key point is that there's other factors that are influencing it. The really important stuff from here is that the built environment is playing a role in this. And that what we can do is we can use models to understand how we should put this bit together. Now, this is just a little bit of an aside. So it's saying, look, if we can't guarantee a positive outcome, we can make it possible if we do things properly. This is a report that came out in the UK in 2021. There's an updated version of it, either just come out or about to come out. And what this found was that something like 80% of developments that happen in the UK are completely car dependent. And that's because of their location, because of the way that sites are selected, because of the local design. It's impossible for people to walk or cycle anywhere. So that's a little bit about kind of why we're doing it or starting to put it together. And so to dig into it in a little bit more detail, there's a question which is about data and why do we need to use models and data for models when you have a whole load of things like live data telling you how many people are in certain places and all of this stuff. And this is a little bit about how to position what we do, really. So if you think through the slides that we've just been talking about, what we're really saying is that the built environment makes some things possible or impossible. And that you might have transport services or other services that can mitigate the built environment, but they have to work within the constraints of this, and they might bring in their own constraints as well. You might be able to get a bus route that connects a bit of the city to the centre, but it still has to work within the existing street grid. And the buses might be really inconvenient. They might be at a really bad time. They might be expensive. They can help to mitigate this condition. They might not completely change it on their own. There are people's perceptions. There are kind of softer layers to all of this as well. So it's not just about the kind of hard infrastructure and the built environment that you can see or the services. There's people's perceptions, and that affects the way that people think about things, and that affects what they do on a daily basis. And as we just saw on the last couple of slides, what people do on a daily basis has a longer term impact on the individual and on wider society. So one way of being able to think about this and to be able to think about how we can use data to understand this better and how we can position models within this kind of sequence of events is to be able to kind of think about the city as like a really simple science experiment. And that doesn't just mean you do what you like to the city and then you see what happens, which is sometimes what people mean when they talk about the city as a lab or as an experiment. What I mean by talking about the city as a science experiment is to say that when you're doing an experiment, you have a set of variables, and those variables are the things that you can change. And if you're doing an experiment, you need to know what can you change, how do you mix them together, what's your experiment, and you need to be able to measure the result. And so what we're starting to do in this is to be able to say, okay, if you're a designer or a planner, or you're in charge of a city, these are the things that you actually have some control over. So these are your variables: built environment, your transport, your other services, and the way that people perceive things. Some of them become a bit more difficult to intervene in, but these are kind of the things that you can change. And the result is the data on what people do on a daily basis and what the longer term impacts and outcomes are. So another way that we can use that is to be able to say, okay, this behavior data, really, if you simplify it, what it's telling you is what happens, where it happens, and when. So it might tell you there's 100 people crossing this road at 9 o'clock in the morning, and you might get that from kind of live activity data. But what it doesn't tell you is why it happens. And the reason why you get those people in that place at that time is more to do with these, the variables, the slow systems that are very difficult to change. So things like your street network might mean that this is a very important street. The distribution of land uses might mean that there's a whole load of employment uses in a certain place. So the reason that these things are happening, you might not be able to get out of this data. And that's where the modeling becomes really important, and especially data on the built environment, because those are the factors which are driving what's happening where and when. They're also the factors that we can change. Now, this data, cities are really difficult to change. They change really slowly. And so you don't need to be updating this stuff all the time, only when there's a major change. I think I would also argue that this live activity data, I think you also don't really need that all the time in cities either. I think if you've got a model that can explain what's happening, if you've got your model and it says why you're getting these patterns and you can see the trends in the data, you don't need to be constantly collecting this data. There's a whole lot of other issues that come from that. So what we're really going to concentrate on is this is what integrated urban models do, is really talk about the built environment and why things happen. And just to reinforce this point about things changing, cities have got a whole load of different systems. They change at different speeds and rates. So here's this idea of this live data. You can see that there's different levels of traffic, different people on the street. That stuff changes minute by minute. Other things which are affecting the city change at different rates. So sometimes economies change very quickly, sometimes they change slowly. So there's political decisions which are made about the way that spatial policy and planning policy happens. Sometimes, if you're lucky, governments change slowly. In the UK, we've had, I don't know, 6 governments in the last 5 years or something insane. It's been changing really quickly. The real point of this is that if you look at the city, you get buildings change over decades. They actually change relatively quickly. But the thing that stays the same for a long, long time is the street network and the patterns of land ownership. So that's why if we're really thinking about planning and design as defining street networks, land ownerships, beginning to allocate different uses and densities to those land ownerships, that's the stuff that survives for sometimes hundreds or thousands of years, and that the buildings might change within that framework. And so that's why it's really important to be able to model and understand these really fundamental bits, which often stay the same for a long time. So a little bit then about integrated urban models, what they are and why they're different. These are some diagrams that people might have seen before. They come from a document that Richard Rogers put together for the UK government a long time ago now, 20 years ago. It was the Urban Task Force. And what they were talking about was the benefit of higher density. Now, the point that I'm trying to make in this slide is that if you think about the systems that you can change in a city, you have the street network, land use, density. These are the kind of the variables that you have as a designer. And what is really important is to be able to understand really precisely the way that all of these different systems combine at the same time. And I think traditionally people have talked about density as a way of being able to understand the city. And this is, I mean, density is quite useful at some levels, but it has its limitations. And the point in this is to say that all 3 of these different areas, they all show the same density. They're all showing 75 dwellings per hectare, but they're all arranged completely differently. And you can see that if you imagine what this part of city would be like, where you have a tower with a lot of green space around it, a lot of car park, that would be a completely different environment to be walking around than this one, which has a kind of shared courtyard, is kind of a perimeter block, I guess, with mixed uses and different things happening at ground level. The 2 experiences would be completely different. And that again would be completely different to a street system with individual houses feeding into it, just in terms of things like the number of entrances that there are, the number of people that would be on the street, the bits that people are more likely to be walking across. So density can't really explain these differences. And that's where we want integrated urban models to drop into. So what we do is we start to think of the city as a set of different systems. Those systems include the ones that we're most interested in are things like urban form. So we have things like the street network, land use, density, public realm, green space, but also some of the mobility systems, things like public transport. And we can take public transport timetable data and we can spatialize it. Now, there's really good data on all of these. You can get street network data from OpenStreetMap or from GeoFabric. You can download it and you can analyze that by itself. You can get really good land use data. You've got public transport timetable data. Now, each of these layers you can analyze individually on their own in GIS. But the thing that the integrated model does is it combines it and it starts to allow you to look at it from the point of a person. So it's not just looking at the street network or not just looking at land use, but it's saying in this example here, this is, we call it the walkability index. We have this for the whole of the UK, where for every building, we walk through every space you can walk through for 15 minutes. We look at the mix of different families of land use. You can get to the number within each family, the distance to the closest one, and we come up with this combined metric. So these red places, if you walk for 15 minutes, you can get to a bigger mix of land uses than if you're in one of these blue areas. Some of the other things that we can do, and sorry, this is just another image showing you the kind of the ingredients that are kind of going into it. So the street network, land use and public transport, and giving you an idea of some of the kind of the ways that you can take the outputs and make them relevant to the questions that you're looking at. I'll talk a little bit more about this later, but it might be about how convenient is it to live in the city? Can people get to healthcare or schools? What's the advantage of having a car over not having a car? So we have these different metrics. We have the walkability index. We have another measure, which is called car dependence. And what we use car dependence for, in this example, this is Milton Keynes in the UK. For every house, what we're doing is going for half an hour by car, and then we're looking at how many jobs can you get to. We're then saying go for half an hour by public and active transport and see how many jobs you can get to. What the colours tell you is the advantage of having a car. So if you're dark blue, you can get to 5 times more jobs in half an hour if you have a car than if you don't have a car. And that's helpful because you can start to look at a city. You can see where is it more car dependent or less car dependent. But you can go into each of those systems individually. And if you said, look, this bit's really car dependent, why is it like that? Could we change the street network? So if you look at this, Milton Keynes, it's made up of this big grid of streets, of basically roads instead of streets, big fast roads. Within that kind of super grid, you have these subdivisions, which are often inward looking and completely isolated. So you might be able to say, okay, can we get a new connection that would connect us to the city centre in a shorter distance that would make it more convenient to walk? You might be able to make that connection, but it might be really expensive. It might be really politically unpopular. So you might not be able to do it. You could look at it and you could say, okay, could we get a bus route to work along here? And then you could start to see, okay, if we get a bus stop here, that might increase the length that the bus route has to go. It slows things down. It makes it more expensive to run. You can start to look at individual interventions and say whether they're possible or not. Now, the really interesting thing, I think, is that when we make it, we can connect it to census data. What that then means is that you can run other models on the census data and you can look at who lives where, although taking into account things around confidentiality and keeping people anonymous. What you can start to do is to see, are there communities who are at higher risk than others? And then you can start to think, well, maybe being car dependent might not matter to some, but it might matter to others. And then you can think about how your social services are delivered. The other things that we can do from this, we don't always have to produce the outputs as a map. We can export them in a whole load of other different ways. And what this is looking at is taking the same information that's in the map and just profiling it as a graph. And what we're looking at is the number of jobs you can get to by active transport versus the number you can get to by private transport, or sorry, active and public. And here we have the mode share information. So at the moment, 80% of the journeys in Milton Keynes are by car. City has a target that they want 40% public and active transport. And what we can see is if you look at the gap between these two peaks, if you've got a car, you can get to loads more jobs within half an hour than you can without a car. If you want to increase your public transport mode share, the gap between these two peaks needs to get much, much smaller. So the advantage of having a car becomes much less. Now, we did test their 2037, I think it was. We tested their 2037 strategy. And actually, the advantage of having a car, the gap between the two peaks got even bigger. So for them to get to 40% public transport mode share was impossible, even from the really early moves about where they were going to extend the city and how they were going to connect it. So you can use them at very, very early stage of design. This again is Milton Keynes, and this is this point about connecting it to census data. And what we've done here is the grey areas in the background are the census boundaries. And we have a model that takes a whole range of different census characteristics, and it talks about the risk of people being elderly and lonely. And so what we can do here is we can see if you're darker grey, the risk is that you have a population which is likely to be elderly and possibly socially isolated. If those places overlap with the dark blue areas, that means you've got a double red flag. So not just is the area car dependent, but you've got a vulnerable community who are living there. So the city can then prioritise going to find out are the people who live here really at risk? What could we do to improve things for them? So the benefits of using the integrated urban model is really that you can make a whole series, you can be really precise about what physical conditions are associated with a particular daily activity. You can start to move also beyond a purely physical intervention. So it doesn't have to be a spatial change to the city. I've skipped past this, but this is really saying we can add in extra data to this. There's lots of data that tells you not just can I get to a doctor, but how satisfied are the patients with that doctor? What's the ratio of doctors to patients? And you can then start to see a whole series of other characteristics. This is a borough of London. And this was looking at how many good doctors could you get to within 15 minutes walk. There's only one small part where you have a choice of good doctors who can actually, with a low doctor to patient ratio. What becomes really interesting is then, again, if you overlay this with the census and you look at where you get areas of deprivation, and it's probably really predictable, depressing story that the places with worse access to worse facilities, which have got lower capacity, are often the places which have got higher deprivation. So then we move on to this section, there's this question about, okay, there's lots of different ways. I think this is links back to why space syntax started as an idea, was this problem that Bill was interested in, which was that places didn't always work the way that designers wanted them to work. They didn't always do what people wanted. And so the question is, okay, so that's why you need to be able to make a model so that you can start to compare one place with another. You can start to link a set of measurable built environment conditions with a set of measurable activities and outcomes. The key point in this, though, is that your model can be validated against those outcomes or those activities and outcomes. So to validate the model, what we did this is in 2022, I think. There's a whole series of studies. I'm going to show you a couple quickly now. One thing that we did was in the UK in 2021, it might have come out, there was a government policy that was to try to get more people walking and cycling. And what we wanted to do was to say, okay, it's really good that people are talking about getting more people walking and cycling. We know there's lots of benefits associated with it. But before everybody jumps in and has their own idea about what needs to be in place to get people walking, we wanted to actually analyze where were more people walking and was there anything consistent about where you got higher levels of people walking. So what we did was we took the model that we had of the whole country, we linked it back to the census data, and we did a whole series of kind of data science and statistical models to see, could we understand and explain where we got more people walking to work. So there was a whole load of interesting bits of data exploration, which were just looking at things initially, things like where was the most walkable bits that we could measure using the walkability index, and what were the typical ages of people who lived in those areas. And what was really interesting was that in the most walkable bits of the city tend to be the centres because there's more uses very close together. In this country, what you tend to find is that it's actually a very narrow slice of population that live in those bits. And really, it's people between the age of about 18 and if you're pushing it 44, it's really 18 to 30. So you get a younger group of people living in city centres. There's a whole load of causal questions to work out in this. One of these questions is if you look at how big houses are, where bigger houses are, typically or often what happens is people at a certain age or maybe have children move to a house where they've got more space, more outdoor space. If you look at house size versus walkability, what we tended to find was this relationship where you get very few 3-bedroom houses or 3-bedroom apartments and flats in walkable locations. And part of this is about this question of density. A bigger house often has more space around it. That pushes the density up. Pushes the density down, increases the distances between things. So you typically in this country, you don't get many, at least not houses which are affordable for families in very walkable places. Other things that were really interesting, car ownership increases at certain ages. Below 44, you get a negative correlation with car ownership. Once people get to 45, car ownership increases, and double car ownership increases. Again, is that happening because the bigger houses that people live in when they're that age are in the less walkable locations? There's a whole load of difficult things to unpick. And then we were seeing these things about city size and car use. And what we were saying was we had a different measure of city size. We weren't measuring it in terms of population or in terms of area. We were measuring it in terms of the spatial network and a particular metric called node count, which I won't explain now. What we were seeing with this was that bigger cities actually had lower levels of walking, but they had much higher levels of active transport, much higher levels of public transport, and much lower levels of car use. So we made what's called a multivariate regression model. What we could do is we could combine 5 or 6 different characteristics together, and we were predicting where people walked to work. This graph here is showing it across 330 different local authorities. What we've done is every local authority is a dot on this graph. The dots have been coloured according to how walkable they are. So one of the things that you can see is in the places where you get higher levels of people walking, you get the red dots. You don't get blue dots in the places where more people walk, and you don't get red dots in the places where fewer people walk. And what that's saying is that basically people are only walking where the built environment makes it possible to walk, which sounds like complete common sense. But the really helpful thing with the integrated model is that with the walkability index, you can be really precise about what is it that makes it walkable. So alongside being walkable, the other things that we found that were really significant were the age of people and households with children. And if you think of it, one of the reasons we think this is affecting it is because if you've got kids at home, you might have to drop them at school, you've got less time to do things. By the time you drop them at school, you probably then haven't got half an hour to walk to work or some of those sorts of things. So there's a whole load of kind of lifestyle questions which are built into this as well. One of the things that was really surprising, you hear this argument a lot in this country, is that people only walk because they can't afford to do anything else. But what we found was that it was really inconsistent. We repeated that model for the 7,000 different areas which the census is recorded at. That's at MSOA. There's another level which is even finer scale, and the model is still working really well at that level. So the reason this is important, there's these 3 things which were more significant. The reason the built environment's important is because it's one of the things that we can change. So if you're a planner or a designer, that's what you can affect. If you run a city, you can't control the number of houses with children, you can't control the age of your residents, but you can do something about the built environment. And the walkability index means you can be really precise about how do you make the built environment walkable. So some of the kind of key bits of information from this, what we found was that if we look at the walkability index, so what we've got here is a scattergram showing walkability index on the y-axis. And on this axis, we've got the length of each edge of an urban block. And what we're finding is that all the red dots are coming into places which have got an urban block edge of around about 100 meters. So between 50 and 150 meters. It's not just about this local characteristic of block size, it's about how it fits into a bigger network as well. And what we've got here is something where we're looking at, again, the walkability index on the y-axis. On the x-axis, what we're looking at is the number of other streets that you can get to from every segment. So most highest bits of walkability, highest areas of walkability, you can connect to between 4 and 7 other segments. So what that really means is that you're part of a street grid where you can get to other things. We used this in a town in Devon called Exeter. We worked on a project with the National Health Service that was about creating healthy new towns. And when they came to us, they said they were building a new town somewhere over here, and they wanted to understand, had they put in place the conditions that would make people more healthy over time, or whether at least associated with people being healthy. And they didn't know what that meant for Exeter, even at that point. So we made them a walkability model of Exeter. This is the walkability index. We gave it to the public health department, and they did this piece of analysis on the right. where they started to correlate obesity against walkability. And what they found was that they got this correlation between the higher the level of walkability, the lower the level of obesity. And they knew the bits that was interesting for them were, and again, linking back to this question about things being complex, they knew that they had a relationship between obesity and deprivation. So the places where people had less money and a lower income, they had higher levels of obesity, but they also had these outliers. They had areas that they couldn't explain, where there were people that were low income, but they were low obesity, and there were people that were high income and also high obesity. And when we gave them the walkability index, they could start to understand the places that were the outliers had an urban condition in place that wasn't there for the others. So the places that were low income and low obesity were the higher walkability. The places that were the higher income and the higher obesity were in lower walkability areas. So they were the more peripheral places. And what that just means is it's just more difficult to be active as part of your everyday life. You have to, it's much more convenient to walk than it is to drive. And that you don't have to say, make an effort to go to the gym in the evening when you get back from work. You go to work in the morning, or you go wherever you're going in the morning, and you probably walk there and you're active throughout the day. It just makes things more, it means that it's easier to be active without making an effort to do it. So I'm going to skip over this because actually we haven't got that long left. But this obviously has a series of implications for strategic planning. Certain places that you can see are less walkable and more walkable. You could start to see, if you were trying to accommodate growth, there will be some places which it's better suited than others. You can start to extract the characteristics to inform local level master plans, especially things around the street network, and how I had that example of Milton Keynes, how it's a set of inward looking kind of subdivisions, rather than, if you look at places that have evolved over time, you get this overlap between, we talk about it as a foreground grid, but we mean the streets which are more important both to the scale of the wider city and locally. If you can align the local and the citywide, you get a whole load of other benefits that happen. If you look at bits of London and compare it to Milton Keynes, you can see that in bits of London, you get it's just much more walkable. If you live in one of these areas which is blue, you can get to one of these orange areas, which means there's a big mix of different land uses. You're never more than probably 10 minutes from at least 3 of these orange areas. If you look at somewhere like Milton Keynes, if you live in one of these blue areas, you might be able to just about get to one of these in a 15-minute walk, but it's very small. It doesn't give the same mix of different things that you could look at, or services you might need to get to. And we can see as well that there are just relationships to how many people walk or cycle to work. This is using census data. At first, these look very similar. The red is meaning that less than 20% of people walk or cycle to work. But what you can see is that there are a series of smaller boundaries within this. Now, because this is census data, each of these boundaries has a similar number of people. If you look at Milton Keynes, there's some of these areas are actually very large. If you look at these bits of London, you get far more census boundaries within that. So even though it looks like you've got a similar amount of yellow in terms of area, the number of people in those yellow areas is much, much higher. So you're getting more people taking active transport. If we look at public transport is much higher in London. And car ownership, number of cars per house in Milton Keynes, more than 50% of people own 2 cars. This part of London, less than 20% of people own a car. There's obviously other questions around the public transport network and all of those sorts of things as well. But you can start to use this modelling and talk about walkability to understand what are the conditions that we should be trying to put in place for kind of master planning? How does it fit into things like the 15-minute city conversation as well, which is probably something that is really interesting to talk about if we've got time at the end. The other thing as well is that if you've got this data, you don't have to make a spatial change. One of the things that we started to do was to work with public health departments to say, okay, we can see mismatches. We can see where you've got a really walkable bit of city, but nobody's walking. What they can then start to do is to try to do a behaviour change campaign. They could talk to the people in these areas and they could say, why don't people walk to work? Because it looks like it's possible. They might find out it's because they don't work there. Maybe they work somewhere else and they have to get public transport. But you can start to think about non-physical ways of adapting the city. I've got a couple of examples really quickly of where we've used these on real projects. Now, I would have shown bits in, I don't know if anybody would have seen the BKIB conference in December, where I talked about the generative process to develop this master plan in the background here. So this was a capital of Kazakhstan, 2018. We won a competition to design the master plan for it. This was the competition submission. We won the competition, and when we started to do the actual project, the first thing that we found was that we were, first of all, only working to 2030, not 2050. So there was much, much less population growth. And what that meant was that we had to change the approach, or we didn't change it, we just focused on a different bit. And what we said was that before you extend the city, first of all, improve it and then intensify it. Now, that then brought up a series of questions. And what we started to do was to say, look, if we have the integrated model, what that allows you to do is to set in place the built environment conditions that enable a certain set of outcomes. But the really important question is, what are those outcomes? What do you want your city to be like in 10 or 15 years' time? So we used this as a way to structure the whole project. So we started to say, what should the city be like in 2030, so in 12 years' time? We could then start to say, we could define from that how you measure that the city is actually doing that and what the built environment conditions are that are associated with it. Once we know those measures, we can use that to analyze the city at the moment. You can use that analysis to pinpoint where you're going to change it. And then you can use those models at the end of the design process to check that your designs are working how you want them to. So we did a lot of stakeholder engagement. We met people that lived in the city and we asked them what they wanted it to be like. What came out was that they were talking about it being livable and sustainable and healthy. On one level, those are really high level, kind of fluffy descriptions. What we wanted to do was get into much more precise descriptions. So we could say, for things like being sustainable, we could give really clear recycling targets or carbon emissions targets. When it came to being livable, we could set targets about walkability. We could set targets about being able to get to school or work or the doctor within a certain distance on foot. When it was about being healthy, we could talk about allowing people to be active every day, so about making the city walkable. What we could then do was use the models and we could say, what's the city like now? And this has all been phrased because we had to present it to people like the president, and we had to be very careful about the way that we explained things. We had to not say this city is terrible. We had to be really careful to say, to kind of raise it as a kind of question and answer thing. So what we were doing was saying, what's the city like now? Is it livable? And we could say, well, look, actually, only 27% of people can walk to school. Is it sustainable? It's increasing the footprint of the city by 90% for a population increase of 60%. And is it healthy? We could see if you had a car, you could get to 8 times more things than if you didn't have a car. So we could use the model and the data to answer these questions. We came up with a way of developing interventions across 3 different scenarios. We had a strategy across the whole city about how we could accommodate growth within the existing urban footprint, about where we were going to concentrate new economic activity. We took 6 different opportunity areas, and we used this as a way to introduce different models for development. So to help the city move away from greenfield development, we took an area like this that we were using for regeneration, and we started to use the tools all the way through it. So we could say, generate a new street network, make sure that street network is integrated with the surrounding city around it. We could start to say, okay, we know the red lines, we're going to have more people moving along them because they're better connected. That means they need to be wider. The less well-connected lines will probably have fewer people, so they'll be narrower. We know there are relationships between putting land uses in certain places. So the red and the orange were more commercial uses with higher densities on the better connected places. The quieter streets were lower density, more residential things. And so we could use these tools through these opportunity areas. But what we could then do as well was put all of the opportunity areas back into the bigger city. We could then run the same measures that we did at the beginning, and we could talk about the benefits that the master plan was creating. So we could increase access to schools on foot by 20%. We could do the things that we needed to do for waste and energy. We could increase the average walkability across the whole city by 10%. In some places, there was no advantage to having a car. We reduced average car dependency across the whole city by 25%, increased access to healthcare by 20% as well. So we could use this as a way to check that the master plan was doing what we wanted it to. The other thing that we did was we trained a group in the city how to use the integrated urban model. We gave them the model and we gave them a plugin in QGIS so that they could then use it to make decisions on a daily basis. That did really well. It won a couple of awards and it was a really good project. The last thing I was going to show you in a couple of minutes was a different way of using it. Instead of making a physical change to the city, this is a project that we did in Sao Paulo. It was called Citizen. And this was really trying to understand how do the people in charge of the city understand how well that supports an elderly population and what can they do to improve it. So there was a whole load of engagement with the people that ran the city. These were their questions they had. They wanted to understand where were the high risk parts of the city, what could they do to change them, where should they prioritize. What we started to do, again, there was interviews with elderly people, and we had this way of categorizing people based on their physical health, from people that were high dependency, meant that they were probably living in a care home. If they were robust, it meant that they were living at home, they were okay. And then we had different levels of income from high to medium and low. And what we started to do was the same data that went into that model of Astana, we were making another model of Sao Paulo, and we were pulling out different metrics. We were talking about how livable the city was, and we were measuring that in terms of opportunities for social interaction, physical activity, access to transport, access to health facilities. And what we did was we ran these models in a way that meant that you could filter them according to how healthy people were and what level of income they had. So this was the thinking behind it, was that if you were robust, in a 15-minute walk, you can walk further than someone who's medium dependency. If you're high income, you've got access to probably a car, and in 15 minutes, you can access a much bigger part of the city. If you're low income, you can probably only walk. So what we had was a whole series of pre-processed data that we were visualizing in a web app, where we could start to click between these buttons, and we could say, if you're robust and low income, where is the highest risk area? And you can see these red areas pop out. What we could then do is we can see how that changes if you move from robust to medium dependency. What we could then do, so this is kind of answering that question of where's the highest risk area. We can then start to say, why are they like that? And based on the interviews with the people who they were talking about it being lonely, or it feels lonely in those parts of the city, we could start to look at this. We had made this metric about access to social opportunities, and we could filter a certain set of land uses. So we could be really precise about what was missing from certain parts of the city. It might not be about social opportunities. It might be about how walkable the area is, or how easy it is to get other forms of transport. So what we could do is we had this way of profiling things as well. So you could talk about where was higher risk, what proportion of people were living in these areas, what would happen if everybody became high dependency instead of low. And this became a tool that the local authority or the city people could use to start to understand how the city made it, how the city was kind of more or less livable for elderly people. There's a tool which is still online, actually, which is not on this list. Oh, sorry, it is. It's this one here. If you follow this link, you can get to the tool that was there. It looks slightly different to this. It's on a free server, so it might take a minute to warm up, but it's still there.